Good morning, good afternoon, and good evening. My name is Whitney, and welcome to the third session of our Media and Entertainment webinar series. Today, we are focusing on automating media and entertainment network provisioning. Our subject matter experts and Arista Systems engineers, Gerard Phillips and Niels Larsen, will lead you through lessons based on their real-world experience. Without further ado, allow me to introduce our first speaker, Gerard.
Hello, thank you very much for joining us. Thank you for the introduction. Niels, can we hop to the agenda? So today we are going to talk through, how automation is really powerful and useful in the media and entertainment world. We're going to talk through kind of the reasoning behind automation, and we're going to talk through a very specific kind of model for automation, which is proving to be incredibly powerful in deploying the sorts of 2110 networks that we see in our world at the moment. So I'll talk a little bit about automation. I'll talk about the kind of network operations journey. We will talk about network as code. You may have heard of network as code. One of the things that really enables automation to work well is patterns and templates. I'm going to talk through a little bit of an example there, cover the modern operating model, and then really we're going to dive into the kind of the real meat of this webinar, which is an amazing set of demonstrations that Niels has generated and will shepherd you through. And they're based primarily on Arista validated designs, which is a set of very capable add-ons to an open source automation tools that you guys can use yourselves, which enable you to really benefit from the experience and understanding of complex networks that we at Arista have built up over many years. And we've managed to kind of capture all of that in a set of high-level tools that you can deploy for yourselves. So Niels will run us through some demos. In fact, the majority of this webinar will be the demos, and then we're going to we'll finish off with some questions from the field. So as well as that, we are also going to fire off a quick poll just before the demos begin, where we're going to ask you guys what you would like to hear about in this series moving forwards. What would be your topics you'd like to hear about? As ever, we have a Q&A window, so if there's anything that kind of crops up, please stick something in that Q&A window, and we have a team of experts behind the scenes who will answer as many of those questions as humanly possible. So let's go to the next one then. So why automation? IP is facilitating amazing levels of connectivity. We're seeing it in service providers and big media facilities all over the place. That kind of connectivity enables huge amounts of media sharing. It enables workflows to become agile and flexible, economies of scale. We're seeing a lot of kind of innovation in the way that these workflows are being put together. Fundamentally, what we're seeing is more and more really large networks. Discovery, NEP, that these networks are all over the place now, and the mergers and acquisitions within this sector means that they're simply going to get bigger and bigger. And as the benefits of connecting stuff together become more widely achievable, then what we'll see is they'll continue to grow. And as these things become bigger and bigger, they become more and more complicated and more difficult to get right. And doing it by hand is becoming less and less of a feasible methodology. It takes too much time, it's too error prone, and it reduces your ability to be agile because you've got to touch a lot of switches to make simple changes. So that's why we're starting to see automation really push into this space. Can I have the next one? And if you look at kind of we call this a network operations maturity model, and it's a set of steps that organizations can kind of work out where they are on this path, and they can work their way up these sets of steps. So if there's not a lot of organization, you end up with all these anti-patterns all over the place. Everything is special, everything is differently unique. Maybe it's not even documented, who knows? As people kind of move up this maturity model, we start to see people deploying stuff with templates and patterns. We start to see the first kind of bits of automation tend to be based on automating and adding in more complex monitoring, telemetry, and observability. That allows you to understand that your system is working well. After that, we could talk about automating the deployment of networks and services, new tenants, whatever it happens to be, new leaves, expansion, new facilities, new DCs. Once you kind of got your head around automating stuff, then you can start to think of that automation in a series of processes, software-defined processes, if you like, network as code, more agile, continuous integration, continuous deployment. So a loop, I'll cover this in a little while actually, a loop of ongoing understanding where you are, monitoring, understanding what you need to change, making those changes, testing those changes, deploying the changes, and then kind of going around that loop forever. And then at some point later on, we see our future as driving proactive network configurations. You'll see AI in there somewhere. You'll see a whole load of proactive fault detection and correction. We're going to look at two of them here. So we highlight the two we're going to look at predominantly. We'll cover patterns slightly, but we're going to talk about the kind of the automation and the inclusion of that automation into a continuous integration, continuous deployment type agile software infrastructure as a code model. Let's jump to the next one. So there's, let me just quickly run over what is continuous integration. What is the continuous integration, continuous deployment workflow? It is, in more detail than I've just said, it is this ongoing virtuous loop of monitoring what's going on, understanding what requirements you may have, determining how to develop those requirements, developing something that you're going to deploy, testing, doing a pre-deployment test of whatever it is you're choosing to deploy. If that's successful, you push that out. If you push it out, then you do some post-deployment testing to make sure it's all working. And then you continue the cycle of observing and monitoring and verifying that your system is working properly. Now, these are all the things that you do as a network engineer anyway. What we're really doing is we're trying to, the CI/CD pipeline is suggesting that this is a more formalized way of seeing that as an endless loop. You're always going to be making changes. You're always going to be growing, adding, deploying new things. You may as well see that as normal. Change is normal. And so if you build that change into a workflow that you can understand, then what you've got is the ability to kind of move away from being slightly scared of change and having to be very, very static, and you can move into a world where your network becomes much more agile, much more capable of growing and developing and delivering the changing needs of your business. In this case, we're going to focus on 2110. So we're going to, Niels's demo will cover some of these elements. It's not a small subject, and what we're showing you here is the use of an awful lot of open source tools or easily available tools that sit in this kind of loop. We're going to cover some of these boxes specifically, but what we are seeing is a lot more kind of move to this agile, much more sort of software agile workflow. Yeah, let's jump to the power of patterns then. So one of the things that drives the ability to automate networks efficiently and effectively is that you can codify the network you want to build. And one of the things that allows you to do that is utilizing patterns. And the move to kind of leaf and spine, two-layer leaf and spine, layer 3, layer 2, whatever happens to be ECMP based networking, collapsing down those layers has led us to the ability to really see this kind of leaf and spine module as a reusable element in a very highly patternable set of deployment models. So let's jump to the next one and we'll see what I mean by that. So, and the next one, so if you think of the traditional red-blue networks we have, or amber and blue in 2110, then clearly you've probably got a leaf and spine that is your red network. Let's add a blue one. So now we've got a blue one. Now, surprise, surprise, they look pretty similar, right? So we've already got a bit of a pattern building here. And typically, if you're building a 2110 network, then you're going to have a management and control network or a monitoring control network. Let's add that one. Now, but that is typically going to follow a very similar pattern. It may be a layer 2 leaf and spine rather than a layer 3 leaf and spine, but it's going to be following an awful lot of very similar patterns. And if you look at that model, actually, you can add in the PTP distribution leaves as well. They're forming the PTP distribution network, but they kind of they look just like they would if they were another pair of leaves. So you can very, very quickly break down what appears to be a relatively complicated network for 2110 and monitoring control and PTP into a series of very reusable blocks. Let's see that on a bigger scale, because the thing that happens on a bigger scale is, let's say you've got a data center and you need to add another data center. Well, those data centers are going to look pretty similar, right? Your main and your backup, or your A and your B, whatever it happens to be, those are they're similar looking things. They're connected together by a big WAN. Let's ignore that one for the time being. But then as you add, regional offices or smaller systems, workspaces, all you're doing is deploying more and more and more of these things that look just like they're just scaled up or scaled down versions of the same sort of thing. So patterns is, you'll see this when Niels talks through his demo. Patterns are a really important feature. It allows you to knock out systems based on templates that are reusable over and over and over again. So let's have a little look at the kind of what we see as the modern operating model. The changes we're making as we move to automation are, I don't want to read through all of these. They're pretty obvious type things. We want to remove human error. We want to move to automation. Machines don't make errors. They do the same thing repeatedly. So as long as you tell them to do the right thing, they'll do the right thing repeatedly. If you move to kind of a modern set of workflows, you've built the ability to revision control your source and your destination code. So rolling back becomes very simple, and some of the other tools available will assist you in that. Much more tricky to do if you've got a switch by switch CLI workflow. So as I say, we're moving away from this device by device change. We're moving towards more network wide changes. So what do I mean by that? I mean, if you're wanting to change the PTP domain, then you don't want to switch. You don't want to touch every one of 50 switches. You want to roll that change out across your network, maybe across A first before B, but you don't want to have to touch every switch. And if you kind of follow this model through, you can making changes much more efficient. So you can move from taking months or quarters to make changes to making weeks or weeks or days to make things. Certainly, we have plenty of experience of rolling networks out now, which can take it takes a little bit of preparation, but the rolling of the network takes way less time. It's much more reliable. Typically, things work much more often first time, and you're kind of removing a whole load of manual testing as well. Let's hop to the next one, where I'm going to talk a little bit about where the stuff that Niels will talk about, the toolset that Niels will talk about, sits in that CI/CD pipeline. So, as I said before, we're not doing anything that network engineers haven't done forever. They've thought about the change, they've designed a change, they've tested it in a virtual environment potentially, or in a digital twin or in a lab. They've determined that's okay. They've rolled it out to that lab. They've proved that works. They've then tested and then rolled it. They then kind of tested it in the full deployment, and they've done some post-deployment testing. So this is all stuff we should be doing anyway. What we're talking about in the oncoming demo is simply that many of those functions are now available within what Arista is calling our open CI pipeline. We're going to touch on a few of those specific tools. And then if we jump to the next slide, so I'm very keen to get beyond my slides because Niels's demo is way more exciting than my slides. So AVD is Arista's validated designs. As I say, it's a series of additions to Ansible or modules that you can use with Ansible. Ansible is open source, free, and it's an automation framework that is being used by many tens of thousands of people around the world to automate many tens and hundreds of thousands of servers, deploying servers and deploying services and software and applications on servers. And so what we're doing is we've sat AVD, which is a set of our Arista specific models and data models and modules on top of Ansible. So it all remains open standard and very standardizable. And within that kind of workflow, you can see that we can glue in some other bits and pieces that Arista can offer, which can add value into this tool chain. So AVD gives you this ability to kind of create templatized, repeatable, Arista validated designs in terms of configurations and testing. Cloud Test is an offering that we have where you can use, we can host a whole series of virtual switches and machines in order that you can do your pre-deployment testing in a hosted environment that you don't have to worry about yourself. And then CloudVision is our single pane of glass that covers network configuration management, and monitoring. And there's some pretty cool tie-ins with AVD to allow you to utilize the power of the kind of change control within CloudVision to give you really clear workflows when you're coming to update stuff. So that was a very quick run through of what we are, the kind of the technology behind and the reasoning behind what we're doing here. So we're going to jump now to the next slide, which is the beginning of the live demo. But at this point, Whitney, can we fire up that poll? So what we're looking for here is we're looking for feedback from you guys. We can see endless ideas about what we could cover in webinars next. The PTP one was amazing, really enjoyed that. Obviously, multicast is at the heart of everything we do in 2110. SDN, MCS, our Arista's own SDN. There's a lot of interest in that. Monitoring, observability, very key to M&E. So what we'd love you to do is to take, take 2 minutes to have a think about what you'd like to see us cover next. Complete that poll while you're listening to Niels and watching his amazing demo. Take it away, Niels.
Thank you, Gerard, and again, thank you to everyone for joining. I have 2 demos prepared for you guys. The first is zero-touch provisioning, so basically how you would provision a brand new Arista network, be it small or very large. In this case, it's a small virtualized network with CloudVision. We will show a simplistic uniform network rollout with one central management platform being CloudVision in this case. And then I'm going to use AVD in collaboration with Ansible to automate the network configuration. So this is a day 1 scenario. You have someone mounting, racking, and stacking the Arista boxes, pulling them out of the cardboard boxes, powering them up, connecting them. And then what will happen is the Arista switch will, on all connected interfaces, it will ask for DHCP address, like so. So the Arista switch here shown on the left, the first it will do is ask for a DHCP request on all its interfaces with a link. After getting the DHCP address with a specific option that includes the URL of the CloudVision server, it will contact the CloudVision server, get its initial configuration, if required, upgrade the software image. CloudVision will then CloudVision will then send that initial configuration and software back to the switch. And then thirdly, a manual operator will then tell or instruct Ansible AVD to push configuration. So the final configuration that will be the running configuration on the switches. This will be pushed into CloudVision, and we will use the integrated change management workflow in CloudVision to review and approve, and then finally execute the change. And CloudVision will then push this configuration into the switches. And in a matter of minutes, we have provisioned either small or large Arista fabric, instead of walking around with a laptop and a console cable in the dungeon or the data center, with the noise and with the lack of proper desk and stuff. So in essence of time, I have recorded a video to show you this. So in this video, you will see here, this is the topology. It's a virtualized network running in GNS3. GNS3 is free to download, as is the virtualized EOS images. So even if you're not an Arista customer, you can get this software, you can try it out in your lab. So in this topology, we have 2 spine switches shown at the top. We have 4 leaf switches at sort of the middle layer, and then what we call sub-leaves, so leaf 1C and leaf 2C. And then finally, I have, again, 2 virtualized Arista switches, but they are acting as servers. And then at the bottom here, we have this out-of-band management switch. This is not connected to the outside networks right now. This is why we have these yellow dots on the connection to the cloud. And what will happen is, when we're not doing anything, when the switches are just powered up, they will continuously request a DHCP address, as you can see the spine doing here. So when I enable the management interface, then we enable connectivity back to the DHCP server and to CloudVision. So you'll see that the spine switch now received an IP address, it received a host name, a DNS domain, default gateway. It has also downloaded the config script from the CloudVision server, in this case 192.168.1.12. it gets its base configuration, and then what will happen is after it requests CVP for configuration, when we jump into CloudVision, the devices will pop up in the inventory. So slowly they will be trickling in. We get an immediate overview of the model, in this case, the VIOS Lab, the software version, streaming agent, IP address, etc. And then we also have this hierarchical container view. And now I'm jumping back to Ansible, and don't be afraid. This is a very brief demo. I will jump into more details about what is Ansible, how does it work. But just be aware that what I'm doing right now is I'm telling Ansible to run a playbook to push the pre-generated configuration from Ansible into CloudVision. So that's what's happening with this script that is running on the Ansible server. So we're generating a full Fabric overview of the entire network. We're generating the configs. We're pushing that into CloudVision. We're generating the container topology on CloudVision for the hierarchical overview. And you will see that change right now. So now we have the Fabric over on the right-hand side. We have one task per device in the change management workflow. So I select all of those and create a change. And I can select here whether I want to run the tasks in series or in parallel. It might be relevant in a production scenario to run changes in series, for example, if you're doing upgrades or whatever. In this case, since it's a lab, we're just doing everything in parallel. So I create a change control. I get the overview of all the changes that are scheduled for the entire Fabric. I get an overview of how many lines CloudVision will be adding to the devices, highlighted in green with the plus, and the blue tilde character shows how many lines will be modified, and the red minus is how many lines will be removed from the running configuration. So I can review all of the configuration for all devices if I like, to see all the differences. So what you see on the left-hand side is the configuration that I will apply to the device, and what is on the right-hand side is what is currently running. So this is the zero-touch provisioning configuration on the devices right now. Then I approve the change, and if I have the need, this could be a 4i principle. So one operator is only allowed to generate and create the change. Another, maybe more senior level engineer is allowed to approve the change, and finally someone completely different could actually execute the change. We can schedule that to run at nighttime or in a change window. But right now we're just executing the change. And now CloudVision is pushing the configuration we just saw into the devices, along with any necessary software updates. So what will happen is all the devices will reboot. And once they have rebooted and come up with the actual configuration, when the change control is complete, then you will see now we have the actual hostname login. So all the switches are up and running, and we can jump to these two Arista EOS instances simulating a server, and now we have connectivity across the Fabric. So this is a full EVPN VXLAN Fabric, not really important, but just to tell you that this is a very easy way to go from a out-of-box installation to a full running Fabric. And this also means that the people that are installing the switches and cabling them, they don't need to be senior level network engineers. It can be whoever you trust with a screwdriver and a cabling plan. And if they do it right, you will end up with a working Fabric. And if they don't do it right and cable it incorrectly, we have ways of identifying that easily as well. So that was the first demo. Second demo is, if we get the slides up and running. So second demo is an actual physical network. So we have a physical media and entertainment lab. I will show you a fully running Fabric without P2P being enabled. And I will show you how easy it is to use AVD to enable PTP in the entire network, including PTP on endpoint ports. And then after doing that, I will show you the integrated validation of the network state, so post-deployment validation, where we query the generated configuration and validate that against the actual running configuration of the network. So we will see if there's any differences. And we will also see how AVD will automatically update and generate documentation, both for the entire fabric, but also per device. So this is the topology in the physical lab. We have an amber spine and an amber leaf 1 and 2. We have a blue spine along with the blue leaf 1 and 2, and then we have the two PTP distribution switches and some grandmasters on top. So this is without PTP. Once we enable PTP, it should hopefully look like this if the demo gods are favoring me today. But before we jump into the actual use of AVD, I just want to go a little bit deeper than Gerard did about what is AVD actually. So Ansible is the open source automation engine. It's not something Arista has developed. It's owned by Red Hat. It can be used for many things, as Gerard also hinted to. It can automate servers. It can automate whatever you can imagine in your IT infrastructure. And in this case, we're using Ansible to automate network provisioning of Arista switches. So we have the automation engine sitting in the middle. Then we have some data input highlighted here in the yellow square on the left-hand side. This could be either static input in form of text files, which will be used in this example shortly. So static input could be one use case. It could also be input from a database or an IPAM tool, some homegrown system like whatever you can imagine. It could be Netbox or Autobot or whatever it's called. Everything you can imagine used for data input can be used as long as you handle the glue. And then the operator input on top, in this case, it will be me, but it could be your networking team, a NOC, or an outsourcing partner. They will instruct Ansible to do something based on the data input and whatever you ask Ansible to do. Based on that, Ansible will push configuration using API calls either via CloudVision, as you saw in the previous demo, or directly to the Arista switches using direct connectivity. So we bypass CloudVision, for example. So you have that choice. If you jump a little bit deeper, what AVD actually is the red square on the right-hand side. So this is what is called an Ansible collection. The Ansible collection contains roles, plugins, modules, etc. It's not really important what that is, but the input from AVD, which is Arista best practices and an opinionated model that makes it very easy to deploy an Arista network without you having to make decisions on how should we configure BGP, for example? How should we configure MLAG? How should we configure PTP? Or all the other variables that are relevant whenever you start to configure a network from scratch. We have taken a lot of decisions for you. You can override those if you don't like it, but if you go along with our recommended ways, you have a lot less work to do. So this Ansible collection will be used as input in a playbook where it's sort of a sports analogy from American football or basketball or whatever. So we generate a playbook instructing Ansible what to do with what data. And another input to this playbook is the inventory. So the inventory is the scope or the list of managed nodes. In this case, the spine switches, the leaf switches, etc., that are part of the actual physical network. That is then input to Ansible, and then we do what I told you previously. We output data into CloudVision. The AVD inventory, or as I said, the scope of the network is shown as here. It's a static file as shown on the right-hand side in black. So we have this hierarchical description of the network At the top, we have this all keyword. It's not important. It's just for all the devices in the fabric. But what is important is the media fabric, the Amber and the Amber spines, etc. So you will see these are all in uppercase, and we have a file with the identical name. So we will have a text file called media_fabric. We will have another called Amber and a third one called Amber spines, and so on. And these individual files, they contain the configuration relevant for that sort of level in the hierarchy. So as you maybe can imagine, the media fabric file would include everything that is generic to all the devices. And if I jump to a file for Amber spines, that would be very specific for the devices that are relevant to that group. And I've just highlighted here on the left-hand side a more graphical overview of the hierarchy. So let's jump into the actual configuration here in AVD. I'm using a text editor that's called Microsoft VS Code. It's not important that it's VS Code. It could be whatever you prefer. I just prefer VS Code. And once you install Ansible, you can and AVD, by the way, you will get a bunch of examples. And by the way, all of this is documented. If I just try to hide these meeting controls, that's documented here on avd.sh. So if you go to this website and click on Getting Started, you will see there's a bunch of examples. For example, single DCL3LS. All of the entire example is documented in detail, and you can download this from GitHub as well. The example I'm using today will be an add-on to this website and will be coming hopefully within July. Maybe later, I cannot promise anything, but there will be a specific media example that you can use yourself. So if we jump back to VS Code, you will have this folder structure. And if I click on the example media, everything that's relevant to what you're seeing today is included in this folder structure. If I open the inventory file, you will see this is identical to the one I showed you in the slides. So we have the definition of the different devices, their serial number. We have some network services, connected endpoints. I will come to that later. And then we have some specifics for the CloudVision server or CloudVision as a service server that I'm using in this example as well. Then we have these group variables, and these group variables are the ones that I said are identical to the names in the fabric. So media fabric, for example, if I open that file, you will see that this is the generic configuration file for the entire network. So we have some, again, CloudVision specific settings. We have a specification of the actual fabric name. We have some node type keys. This is AVD specific, again, to sort of control the different characteristics of the different types that we use. So for the PTP leaves, for example, we don't have any overlay routing protocol specified, or the same for the spines and media. If we were using like a traditional data center network with EVPN VXLAN, for example, we would specify a routing protocol. It accepts what we call connected endpoints, so specification of a port connected, for example, to a ground master or a camera or microphone, whatever. Some network services, layer 2, layer 3, and then a default PTP priority 1. And you can see they are different on the different levels of the network. Then we have a bunch of other generic settings, users, passwords, BGP, etc. And then what's interesting is the PTP that you will see later here. So if I uncomment these two lines and run the playbook, I will enable PTP in the entire network. Right now, we don't have any actual configuration in the Ansible inventory because I haven't run the playbook yet. So I will run the build playbook, and before I do, I'll just show that where we have it. Here we go. So this is the playbook, the sports analogy, where we build configurations and documentation. So this playbook will generate what we call AVD structured configuration and the fabric documentation. And based on this fabric overview, We also generate the specific device configurations and device documentation. So when I run the playbook, you will see that the configuration directory and the documentation directory will suddenly have a lot of files in them, one per device. And this AVD in Ansible is running locally on my laptop. Typically, you would probably run this on a server in your data center, depending on your requirements. So now we have the structure configurations. So if I open the configuration for Amberleaf 1, you will see this is in YAML format. There's a bunch of BGP configuration, etc., etc. And based on all of this in this file for the entire fabric, we've also generated the actual EOS CLI configs. There's a bunch of aliases, the configuration for our CloudVision Terminator daemon, responsible for the real-time telemetry streaming, host names, etc., usernames, and switch port settings, etc., etc. And you will notice that, for example, this Ethernet 1 is configured to use VLAN 111, but there's no PTP configuration. There's also no generic PTP configuration on this device at all. And finally, we have the documentation. So for the fabric, we have a fabric documentation. And let me just get this video window out of the way. So if I open that in a preview, this is in Markdown format, you will see that for the fabric, I have an overview of the switches with the management IP, the serial number, the topology, so which switch is connected to which switch with which interfaces, etc., based on the configuration that I've specified. So you can visually verify if you've made any errors in the configuration. You will also see the IP allocation, so the statically assigned IP pools, how many addresses are available, how many do we use, and the percentage used. The same for the point-to-point links, loopback interfaces, etc., etc. So that was for the fabric. And if we move to a device documentation overview, let me just get this out of the way. Yeah, so here we have the full documentation per device, management interface with the actual configuration snippet, same for the DNS, name servers, NTP, etc., etc. All of this is available to you automatically and automatically updated whenever you run the playbook. So let's try to enable PTP, because this is the actual configuration where we do not have any PTP configured. And to prove that, I will jump to, let me just close this video. I will jump to CloudVision. So we have the switches in the inventory here, Amberleaf 1 and 2, along with a bunch of other devices that are not relevant for this demo. I've created a dashboard showing PTP relevant information for this topology. You will see it's disabled right now. So let's jump back to AVD, and we will just uncomment these two lines. If I run the build playbook again and jump back to the configuration for Amberleaf 1, you will see that shortly there will appear some global PTP configuration for this device. If I can remember exactly where it's going to be input. At least we can also keep an eye on Ethernet 1, because that will also have PTP configuration. So let's see how far we get. Now we're updating the fabric documentation, and we are moving to the actual configuration. So shortly this should be updated. If the demo gods are working in my favor. Here we go. So now we have the global PTP configuration. We have automatically generated the clock identity for PTP, the priorities, the domain, the monitor thresholds, etc. Sorry. And you will also see that there's PTP configuration for the endpoints. And I see I made a mistake here because AMPA VLAN 1 is not enabled for PTP. So we can jump to the connected endpoints and you will discover I had uncommented or commented the PTP enabled command, meaning that this port profile will never receive any PTP configuration. So instead of wasting your time and running the playbook again, we can go through these settings for the connected endpoints where we can use port profiles to quickly generate configuration depending on the different needs. I also have some generic settings to specify the settings, in this case for Ethernet 1 to 48. They will all receive the profile AMPA 111. Other switches will receive other profiles. So in this entire file, I have my endpoint configuration for the entire fabric, be it very generic or very specific, and the very specific setting will override the generic settings. So for example, I have a specific configuration, in this case for AMPA 1 Ethernet 6, with a description, speed, type, a routing interface with an IP address, PIM enabled, multicast, PTP, etc., and so on. This is just a static example. This could be generated by pulling input from a database or from an IPAM tool or whatever. The idea is just to show you that AVD can be used both for day 1 operations, but also for day 2 operations. So now that we've added the PTP configuration to the switches, let's push the actual configuration to CloudVision. And I do that by running another playbook, deploy CVAS, it's called. And if we look at that, it's basically, it looks like this. So we run the role that is called AVD EUS config deploy CVP. We have some specific settings for this container hierarchy you saw earlier, some settings for how to apply settings to the containers and to the devices, and whether we want to have CloudVision just execute the tasks blindly or to use the actual change management workflow. In this case, we're using the change management workflow. So what will happen here is I have now 8 tasks waiting for me, as you saw in the previous demo, 1 per device. I select those, create a change control, again, select parallel mode. I create the actual change control. I can see how many lines will be added. If I do the review, you will see that now I'm adding the PTP settings, both globally, but also per device. And I can see that again for all the devices in the fabric. I approve the change and execute the change. So this should be done very quickly, and the dashboard will show you in very near real time. Once the configuration has been applied, you can see now the boundary clock is enabled on the various devices. And shortly, PTP should start getting actual data from the Grandmaster. Crossing my fingers here. It worked earlier at least. Let's see how far we are. That is complete. Is the change also complete? No, not yet. So we're still waiting for the change control to complete. And we can look at the actual logs. Oh no. This is not good. I guess the demo gods is not on my side today. but it seems as if PTP has I think what's happened is that I've messed up in some authentication between CloudVision and the actual switches, but the change has been pushed, and you can see that the Grandmaster is configured. We have the offset values, etc. And then what we can also do is we can go back and do the post-deployment validation. So we can run another, playbook called validate. And what this playbook will do is it will actively inquire. No, it won't. Yeah, I'm out of luck today, I see. What would have happened is that AVD would actively inquire the devices about the actual state. It would use, for example, LLDP to identify any miscable connectivity. It will show up in a report, again in Markdown format, highlighting, for example, what power supplies doesn't have power. Are there any third-party optics in the fabric? Is there a link that I expected to be up that is no longer up? Is there a routing daemon configured that requires a reboot, for example, or et cetera, et cetera. So this makes it very easy to get a very fast overview of the state of the actual fabric. Did you cable it correctly? Did you insert the power cables? That will be done within minutes compared to doing an actual physical inspection in the data center, walking around, checking the cables, checking the LEDs, doing show commands on devices, etc., etc. All of that in a matter of minutes. And I apologize that for whatever reason my demo is not working. Yeah, that was not the intent. So let's go back to the presentation. And what did we demo? We demoed the zero-touch provisioning, where you saw an out-of-box fabric being configured using the native Arista zero-touch provisioning mode that comes by standard, provisioning the fabric using CloudVision and Ansible AVD. Then we saw how to enable the P2P across the fabric using AVD again. We saw the use of CloudVision change control, the streaming telemetry in the dashboard. You should have seen the automated network state validation. I'm sorry you didn't, but you saw the automated network documentation at least. Then we have some commonly asked questions. And should I hand over to you, Gerard?
Yeah, go for it. So Niels, that was amazing. Thank you. I really enjoyed that. And I have used that validation step in the past, and I found it to be unbelievably valuable in verifying that everything is connected as it's supposed to be connected, which is typically something that isn't always done. You know, red devices are attached to blue switches, etc., etc. So I guess what I'd say here is we can rerun these demos as many times as we like. So if there's if there's anybody out there who wanted to see some of these demos in more detail, then please reach out to your account team or sales@arista.com or Niels or I on LinkedIn. However you wish, reach out to us and we'll organize a demo in a little bit more kind of sedate fashion. There was a huge amount of stuff to cover here, so I really enjoyed that. Thank you. So what we got now is we're going to use the remainder of the time. We're going to kind of hop through some questions which we often get asked as a way of just kind of clarifying some bits and bobs that some bits were kind of talked about, but these seem to be the ones that come up most often. So Niels, can we use AVD to validate other vendors' equipment, or sorry, to automate other vendors' equipment?
Well, by default, I would say not really, no. It's built for automating Arista switches, but what we can do is we can integrate AVD with other playbooks for other vendors. That is up to the customer to do that, but certainly the automation engine can run whatever it needs to be doing. We have customers using multi-vendor deployments and using AVD in collaboration with other playbooks to run other configuration tools for other vendors. So certainly it can integrate in some way, but it is generating Arista EOS, which would not apply to one of our competitors' switches.
But I guess that's the power of building this on top of Ansible, right? You could use any other playbooks, et cetera, tools,
Exactly.
modules you could use stuff in the same playbook. It's just that the bits that you want for Arista will be using AVD, and the bits you want for something else will be using something else. So I think maybe it's a badly worded question. I have seen that CVC Canada have built some automation of some of their endpoints. I believe there's even a repository with that in it. So yeah, I guess the answer sort of is yes. What's the next question now?
Yeah, the next question is, what if there are features I need that are not there? And in this case, in AVD.
Yeah, good question. And so I guess the point is it's very extensible. And in fact, the PTP is a great example of that, right? That PTP support did not exist 6 months ago, 8 months ago, maybe. I mean, you took some time and you wrote that. So
yeah,
there are definitely paths to people writing their own add-ons to cover things that need to be covered. In AVD itself, we cover basic dynamic multicast. We can cover, you can configure static multicast. You can configure MCS as our SDN, so you can deploy. In fact, you can configure MCS itself, and you can configure the client end of that as well on the switches. So it is a very, very flexible tool that you can continue to add stuff to if that's how you wish to use it. Yes.
Exactly, and I also want to highlight that, you know, customers that are, you know, a little bit savvy, they can also generate pull requests or add features themselves. They are more than welcome to contribute in whatever level they want. They can, you know, generate feature requests, or they can build the features themselves, and our team will review and integrate them in AVD if at all possible. We also have, even though it's an open source project, we have a paid option, so you can pay for actual support for AVD, so getting you a little bit, you know, sleeping better at night if you're worried about using open source tools, which you shouldn't be, by the way, at all, because we have a lot of very large customers running this to a great success. Next question. So that's you, I think.
Yeah.
Gerard.
So how do we, for example, in a lot of 2110 networks, the kind of hosts requirements are defined in a spreadsheet. How can we? You showed some host definitions in the AVD. What can I use to describe what my host ports need to look like?
Well, you can use, I would say, almost anything depending on your requirements. As you said in the example, it was just a simple static YAML file. We have customers using Netbox, Autobot, Infoblocks, Excel spreadsheets. And I know that Arista has helped develop integrations with some of these tools. If they don't exist, we can definitely help with that as well, as a paid service from Arista Advanced Services or Professional Services. Or if the customer, again, is a little bit savvy and knows how to use APIs and so forth, they can build the glue themselves and integrate whatever requirement they have to generate these host ports needs for, you know, day 2 operations.
Cool.
Third question, is this just about day 1 provisioning?
Yeah, I think if you hit the button, there should be a little diagram.
Here we go.
So yeah, so no, it's not. I mean, typically it can be day 1 provisioning. Obviously, makes a lot of sense there. It can be ongoing network provisioning, ongoing kind of change generation and maintenance, for example. So it kind of depends what your workflows are, whether you have the skill set to see this through, whether you're prepared to kind of move to this continuous integration, continuous deployment type model. So yeah, it doesn't have to be just day 1, but it certainly can help greatly with day 1. What's the next one? And what about after day 1 then? What are the options for after day 1?
Yeah, so one thing that is coming up that we haven't showed in this demo, and we didn't show it in the essence of time, and I just also want to stress this was a very high level demo. I tried my best not to dive too deep, and maybe some of you are sitting back with your head spinning. So again, as Gerard said, please reach out to your local account team, and we can do a much more detailed, much more slower paced demonstration and talk about it. But One thing that is coming up is the use of CloudVision Studios with a GUI, as shown here in the screenshot on the right-hand side. So day 2 operations can be done using CloudVision Studios with a GUI, and further down the line, we will do some more integration into CloudVision with AVD. So Gerard, do I need to use CloudVision at all?
You don't need to. No, I mean, Niels, you did a great demo of pushing the configs in through CVP, but you don't need to. You can use the eAPI path to push the configs onto the switches if you don't want CloudVision. You have to build your own change management. Or to be honest, if you really wanted to, you could build, just build configs and do something else with them. But you're kind of defeating the point of the process if you're not going to then push them in an automated fashion, I'd say. So yeah, not mandatory at all.
No, exactly. And maybe also to iterate, the change management workflow in CloudVision gives you the benefit of being able to do a rollback. So if you find out that you messed up in the configuration, you can do either a manual rollback, or if you do a serious mistake, which I think I did actually, then the devices will roll back after 4 minutes if they, for example, lose access to CloudVision, which I think was what happened in the demo, and they will automatically roll back to the previously running configuration. That will not happen if you do a direct connection via eAPI to the switches. So you will have to, if you want the ability to roll back, which I think most customers would, you need to develop that yourself.
So what support for 2110 does AVD provide?
A lot of stuff. I think you covered most of them, Gerard, already. But for example, the PTP features, we have integrations with MCS, so we can use AVD to generate the MCS configuration to integrate with broadcast control systems. We have a lot of integrations already built into AVD for media and entertainment at 2110, and more to come. Again, if you are either an existing or new customer and you see AVD as exciting and you think, can it do this or that? Please reach out. We are more than happy to help, and we are very eager to promote the use of AVD for M&E customers.
So we're right on the hour. I think maybe we just run through these last 3 very quickly, and then we'll just wrap up with the conclusion. So do I need to be a programmer to do this?
No, you don't. It seems to some as a sort of a very steep learning curve, but I would say my actual experience with customers, with people of 20+ years of experience using CLI and a console cable in the data center, once they see the benefit of automating the configuration, once they learn how to use a text editor and the format of the different files, you don't need to be a trained programmer or have a lot of programming experience, by no means. But yes, it might seem a little bit daunting at first, but we're here to help. I think that's also the key message. And do we have any examples, Gerard?
Yeah, so CBC is using Ansible at the moment, certainly. I think they began their process a little bit earlier than AVD was available. So certainly it's being used by proper big grown-up broadcasters. And of course, the whole of the JCM tested network built in Wuppertal in August 2022 was built off the back of AVD using your amazing PTP, and it pretty much worked first time. So yes, absolutely, there are definitely people using it, and it definitely works.
Yeah, and you were there on the ground, right, Gerard?
I was on holiday. I built it and went on holiday.
Oh, that's how effective AVD is.
Yeah, that's right.
Yeah.
And what's the best way to learn and get started?
Well, we have our brilliant online resources, but I would say reach out to your local account team. They will put you in contact with the relevant people. They will instruct and train you themselves, help you get started. If you have any interest, I'd say that's probably the easiest way. Contact your account team if you're not keen to just start browsing a website and going at it. That's our recommendation, and we're here to help.
Cool, sounds good. Okay, so yeah, let's go to the takeaways. Thank you so much for everyone who has stayed the full hour. It's a very packed agenda. We've covered a lot of stuff. There is a recording. You will be able to access the recording later, so you'll be able to watch it in slow time. If any of this stuff is interesting to you, then please just reach out to your account team or to one of us through LinkedIn or through email. We'll be very happy to assist and to rerun whichever bits you'd like to see. But the bottom line is this automation is being deployed widely in the kind of wider IP industry, and if media entertainment can jump on the back of this, then what we'll discover is we can really reap some amazing rewards, reducing human error, kind of enforcing templates and patterns, which makes sense anyway. We heard about the generation of the documentation, the automation of documentation. Who generates documents when they're supposed to? Nobody, right? So if your process generates them automatically, you're so far ahead of the curve there. And if you can move to a kind of process where you have small continuous changes and you're able to verify and test the pre-deployment and post-deployment, especially with that validation check, then you're in a place where change becomes normal. And once change becomes normal, you become way more agile and way more able to kind of cope with anything that hasn't gone the way that you wanted it to go to. So please reach out. If you're going to be in IBC in September, please drop by and have a chat. But thank you so much for your time, and we will we'll review the poll and we will let you guys know what the next webinar will be soon. Thank you, Neil, so much. That was amazing. Thank you very much.
Thank you. And thank you to the attendants.